Alright, so here we are going to solve a right triangle given two sides. And the way we know that it's two sides is because here it tells us this is a right triangle ABC. So we know we can draw a right triangle like this. And we know that our hypotenuse is always going to be C. So if our hypotenuse is always C, our triangle ABC would have C here, and you can write A or B in either place. But you always want to make sure when it tells you have a right triangle for ABC, you always want C to be the right angle so that it's across from the hypotenuse. We always want side C to be across from angle C, side A to be across from angle A, and side B to be across from angle B. And we put sides in lowercase and angles in uppercase. Just like we normally would label a triangle with our angles in uppercase. You guys are used to that. But it's just adding in the fact that we always want our lowercase side to be across from its opposite angle. So here we have C is 53.58 centimeters. And again, we also know it's a side because it says centimeters. So we know that angles aren't measured in centimeters. And then we have side here, 29.43 for side A. And now we want to solve the right triangle using a combination of trig, inverse trig, and Pythagorean theorem. So here we have, we can find any angle that we want. It doesn't really matter which one, but we do need to find an angle at one point. So you can pick whatever you want. I'm going to start with angle X. So I'm going to find X, and from X's point of view, this is the opposite, and this is the hypotenuse. B is the adjacent, which we do not have. So I'm going to pick sine. So my sine of X is opposite over hypotenuse. And I'm trying to find my angle, so this is actually going to be inverse sine of X. Remember, anytime we're trying to find angles, we are looking at inverse. So when you get your calculator, remember you always want to check your mode, make sure you are in degrees, or else your answer will be very wrong. And then we're going to type in second sine, so it's an inverse, divided by 53.58, and we get 33.317 degrees. And that is our angle A. So that's one piece of the triangle we needed to know. We also need to find angle B. Well, angle B we can find using trig if we wanted to. We could do adjacent over hypotenuse, since from B's point of view this would be the adjacent. But we don't have to because we have the angle sum theorem, meaning the whole triangle has to add up to 180. So we have 90 here, we have 33.317 here. We can add